So this is the key for the review for Unit 3. We're going to look at all the graphing and then different things about the equations and then actually eventually write equations of graphs. Number 1. Okay, there are 4 steps. I'm going to write them at the top so you can have them for the whole thing. So step 1. Okay. Step 1, find the period and intervals. Step 2, do the horizontal shift. Step 3, find the first point. Step 4, use the amplitude to finish the graph. Okay, those are the steps you should have to graph all these equations. Okay, they work for each one. It's a little bit different for tangent and cotangent, but it still applies. So here we go. Step 1, find the period and the intervals. Okay, so nothing is being multiplied or divided by the x term. It's by itself. Now there's something subtracted, but that's going to be the horizontal shift. So that means your period is 2 pi. So we're going to write down our intervals down here. We have 2 pi, we have pi, pi over 2, and 3 pi over 2. Okay. That's the first step. Next, the horizontal shift. The horizontal shift is found when something is being added or subtracted inside the parentheses, so that negative pi is going to be your shift. We've got to figure out from the y-axis to pi, how many intervals is that? It's 1, 2. Since it's minus pi, we're going to add to the right. So if we add 2 spots to our intervals, this will be 5 pi over 2, and it'll be 3 pi. Okay. So now we know our graph's going to start at pi on the x-axis. Next, find the first point. So we're going to do 5 times cosine, which starts at 1, and that equals 5. So if we go at pi and go at 5, our first point will be right there. Step 4, use the amplitude to graph the rest of the points. So the amplitude is 5. So we're going to go down 5 more, up 5, and up 5. And there we will graph. There we go. All that stuff is necessary for your graph to get a 4. You need the intervals, you need all the points, you need them in the right spot. Okay. Number 2, find the period change. Now something is being multiplied or divided by with the x, and that is the x over 4. So we're going to set that equal to 2 pi, since our standard period for a sine or cosine graph is 2 pi. And multiply by 4 on both sides to get x by itself, and x will equal 8 pi. So we take 8 pi and we make our intervals. So here's 8 pi, half of 8 pi is 4 pi, half of 4 is 2 pi, and 3 times 2 is 6 pi. Next we do our horizontal shift. There is no horizontal shift. Nothing is being added or subtracted inside the parentheses, so no shift. That means we can skip step 2. Step 3, find the first point. So we have 3 times sine, which starts at 0, plus 2 equals 2. So our first point will be at positive 2. Step 3, step 3 is completed. Step 4 would be use the amplitude to graph the equation. So the amplitude is 3. So we go up by 3, down by 3, down by 3, right there, and then up by 3. There's your sine function. Next, tangent. All right. Now, tangent and cotangent a little bit different than secant, cosecant, sine, and cosine in terms of period, because the period for a tangent and cotangent all is at pi, not 2 pi. So since the period is changing because something is being multiplied or divided by the x, we have 2x equals pi as our standard period. We divide both sides by 2, so x will equal pi over 2. Now remember, for a tangent function, that period is divided into two pieces on either side of the y-axis. So half of pi over 2 is pi over 4, because half of it goes over on this side, half it goes on the other side, so that's going to be negative pi over 4. Half of pi over 4 is pi over 8, which means the other side is negative pi over 8. So from negative pi over 4 to positive pi over 4 is pi over 2 for one period long. Okay, there is no horizontal shift for step 2 because nothing is being added or subtracted inside the parentheses. So we can put our asymptotes on either side of our period. All right, next do the shift, or sorry, find the first point, my apologies. Find the first point, tangent starts at 0, minus 2, so we're going to go down 2 spots, then graph our equation. So the amplitude is 1, so we go up 1 and to the right, down 1 to the left, and we're going to graph our tangent function just like that. Okay, number 4, cotangent. Step 1, find the period and the intervals. There is nothing being multiplied or divided by the x, so the x value is going to be pi, because that is the standard period for a cotangent graph. Now, cotangent is not divided by the y-axis like the tangent graph is, so we're going to put pi there, put pi over 2, pi over 4, half of pi over 2, and then 3 times pi over 4 is 3 pi over 4. Making sure that we put our intervals down. Step 2. Horizontal shift. Since we're adding pi over 2 on the inside right here, means we're going to move to the left by pi over 2. How many intervals that is 1, 2. So we're going to move 2 intervals to the left. So we're going to be at negative pi over 2 over here, and negative pi over 4. So although the cotangent graph does not normally get divided in half by the y-axis, because this is shifted 2 spots to the left, it will be. So we can put our asymptotes here, and then at positive pi over 2. I'm going to erase my interval stuff. Okay. Next, the first point. So there's nothing being added or subtracted on the outside, so cotangent starts at 0. Goes up 1 to the left, down 1 to the right, and there's our graph. There's our cotangent graph. Okay. Question 5. Now we do secant. Now for secant, we're going to graph the cosine function and then graph secant on top of cosine. So step 1, we take our period and intervals. Since our x is being multiplied by 4, we have 4x equals 2 pi. Divide both sides by 4, and we get x is equal to pi over 2. So our intervals here start at pi over 2. Half of pi over 2 is pi over 4. Half of pi over 4 is pi over 8. And 3 times pi over 8 is 3 pi over 8. Okay. There are no horizontal shifts because nothing is being added or subtracted inside the parentheses. Go to the first point. We have 2 times the cosine, which starts at 1, which equals 2. So we start at 2. There's our first point. We use the amplitude of 2 to graph the rest of the function. So go down 2, up 2, and up 2. There we go. Oh, my bad. I was graphing a cosine function. We are graphing a secant function, so this should be a dotted line. And I'm going to put the asymptotes here and here. I apologize if you started to graph the cosine function. All right, I'm going to change colors for the graph itself. You don't have to do this, but I'm going to do it. You're going to make a parabola type shape through the points on the peaks and the valleys of your cosine graph. That's what it should look like. Okay. Now the dotted line is because we're not actually seeing that graph. That is the template which we're going to use so we can graph the secant function. Go back to blue. All right, let's do cosecant. Cosecant, we're really graphing the sine function. Nothing is being multiplied or divided by x, so our period is still 2 pi. So we got 2 pi, we have pi over 2, and 3 pi over 2. Okay, but we have a horizontal shift this time. We're going to the right by pi over 2, so that is one interval. So we're going to add an interval to the right side of our intervals that we've already got down. So after 2 pi is 5 pi over 2. Okay, let's erase this little interval spot. All right, for the first point, we have -1 times sine, which starts at 0, which gives you 0. So our first point is at pi over 2 and 0. All right, we use the amplitude to graph the rest of the function, but this negative sign, this means that the graph has been flipped upside down. So it's going to go down first rather than up, then up again, then down. So it's going to be upside down. And I'm going to do my dotted line on the sine function. Okay, where the graph, the midline of the graph vertically is going to be, we're going to put our asymptote, actually I don't like that asymptote. Sorry about that. There's my asymptote. I like that better. Okay, I'm going to put my asymptote through these points. Notice these are not the peaks nor the valleys. They're the middle parts of the graph. On the peak and the valley, I'm going to make my parabola type shapes. So on the valley, I'm going to go down. And the peak, I'm going to go up. There's my graph for cosecant. Okay. All right, let's try some more. Again, nothing is being multiplied or divided by the x term, so our period is still going to be 2 pi. Come over here, do 2 pi. Half of that is pi. Half of pi is pi over 2. And 3 times pi over 2 is 3 pi over 2. Okay. We have a horizontal shift. We're moving to the left by 3 pi over 2. That is 3 intervals from y. So we have to put three intervals on our graph, or sorry, on our graph for our x-axis. So this is -3 pi over 2, negative pi, there we go, and negative pi over 2. So we're going to actually start our function, or our graphing, at -3 pi over 2 on the y-axis. Now we've got to figure out the first point. So we have -1 times cosine, which starts at 1. So I'm going to start down here at -1, because that's what that equals. Sorry. Skipped a step. All right, next, use the amplitude to find our rest of our points so we can graph it. The amplitude is 1, but it's upside down because of this negative sign. So we're going to go up first, then up again, then down, and down. Okay, so our function will look something like this. Now, since we are graphing cosine, we're going back to solid lines. It looks a little bit like that. Number 8. Period and intervals. So our period is being multiplied by 2. The x is being multiplied by 2. So we have 2x equals 2 pi. Divided both sides by 2 to get x by itself. And x equals pi. So we go to our intervals. We have pi over 2. Half of that is pi over 4. 3 times pi over 4 is 3 pi over 4. There's no horizontal shift because nothing is being added or subtracted inside the parentheses. So we go to our first point. We have -3 times sine, which starts at 0, which gives you 0. So our first point is at 0. Our amplitude, step 4, is 3, but it's upside down because there's that negative sign. So we're going to go down by 3, up by 3, up by 3, and down by 3. There's our graph. All right. Number 9. Doing cosecant. That means we're going to graph a sine function. Nothing is being multiplied or divided by the x, so our period is still 2 pi. So I write our intervals down. We have 2 pi. There we go. Half of that is pi. Half of pi is pi over 2. And 3 times pi over 2 is 3 pi over 2. Okay. There is a horizontal shift. We're moving to the right by pi because it's being subtracted by pi on the inside of the parentheses. So pi is 2 intervals to the right. So we're going 2 intervals to the right. So it means we're going to add to 2 pi on the bottom here. You get 5 pi over 2 and 3 pi. Again, if you don't know how that works, you're not sure how we got 5 pi over 2 and 3 pi. All right, look at the intervals that we have. We have 1 over 2. This is 2 over 2, which is just 1. This is 3 over 2, 4 over 2, which is just 2, 5 over 2, and 6 over 2. We're just adding a number to our first numerator all the way down. Okay, after 3 pi would have been 7 pi over 2. Okay, so it's not really all that tricky. All right, back to our problem. We've done our horizontal shift. I'm going to erase all these things down here just so we're not confused. Okay. So our first point, we have 2 times sine, which starts at 0, which is 0. So we go at pi at 0, because that's what we shifted over by pi. All right. We use the amplitude to graph the rest. So we're going to go up by 2, down by 2, down by 2, and up by 2. That is the pattern for a sine function. But we're going to make this a dashed line. It's not really graphing sine, we're graphing cosecant. All right. The midpoint of the graph, we can then do our asymptotes through those 3 points. And then we're going to graph the cosecant function on top of the sine function. So at the peak, we're going to go up. At the valley, we're going to go down. Okay. Next, we have a secant function, which means we're going to graph cosine. All right. Something is being divided by, or x is being divided by 2, so we have x over 2. This is going to change our period. We're going to multiply both sides by 2, so x will equal 4 pi. Go back down to our intervals. So we have 4 pi. Half of 4 is 2. Half of 2 is 1. 3 times 1 is 3. All right. There is no horizontal shift because nothing is being added or subtracted on the inside of the parentheses. We go to the first point. So cosine starts at 1 plus 3 on the outside, which gives us 4. So our first point is going to be at 4. The amplitude is 1 on the front end of the cosine or the secant function. So we're going to go down by 1, up by 1, and up by 1. Since we are graphing secant and not cosine, we're going to make this cosine part of the graph dotted. That's kind of ugly. There we go. All right. We're going to make our asymptotes through the midline of our graph. All right. If you're putting an asymptote through a peak or a valley, you're doing something wrong. On the peak, we're going to go up. The valley, we're going to go down. The peak, we're going to go up. And there is your secant function. Okay. Next, tangent. So nothing is being multiplied or divided by the x, so our period will not change. But remember, again, tangent is divided into 2 pieces on the x-axis. So we have pi over 2 on this side, negative pi over 2 on the other side, negative pi over 4, and positive pi over 4. So the period of a tangent function is 1 period long. From negative pi over 2 to positive pi over 2 is 1 period. Is just pi, sorry. All right. Next, the horizontal shift. We are moving to the left by pi over 4. Okay. So if pi over 4 is 1 interval on our graph, we're going to move 1 interval to the left, which gives you negative 3 pi over 4. Okay, that's going to become the end part for our asymptote. We're going to move over 1 spot to the left from positive pi over 2 to be at negative pi over 4, or sorry, positive pi over 4 for the other side of the asymptote. Okay. Tangent starts at 0, but we have a minus 2 on the outside for our first point. So we go, usually the graph for tangent starts at the origin. We're moving it over 1 spot to the left and down by 2 because the whole graph got shifted 1 interval to the left. And the minus 2 makes our graph go down. Now, for tangent, we go up to the right, down to the left, and graph our function. There you go. I think this is the last graph. This is cotangent. Because something is being multiplied by the x, we're going to have 2x equals pi, because the cotangent graph has a pi for a period. Divide both sides by 2, so x will equal pi over 2. All right, now, cotangent is not divided by the y-axis like tangent is, so this is pi over 2 at the end. Half of that is pi over 4. Half of that is pi over 8. 3 times pi over 8 is 3 pi over 8. So those are the intervals. Step 2, find a horizontal shift, which there is none. Nothing is being added or subtracted inside the parentheses. All right, so that means our asymptotes are going to be here on the y-axis and here at pi over 2. Okay. Cotangent starts at 0. There is no vertical shift, so it's going to go up to the left, down to the right, and then we can graph our function. Okay, that is the graph part. Let's look at the rest of this review sheet. Okay, so we are given a graph and 4 equations, and 2 of these are equations on our graph. All right, so let's go through them in order, okay, and we can do the process of elimination. Okay, so the period of all these is going to be the same. You can see on all the equations, the x is not being multiplied or divided by anything. So the period is 2 pi. We can see that if you start the graph here and do a reflected sine function, that's what it is. So that's kind of what this first one is. Negative 2 sine starts at 0. It goes down 2, up 2, up 2, and down 2. That is that function starting at this point right here. So this is A. So that does work. Next, for B, we have negative 2 cosine, the quantity x plus pi. So we're going to move 2 intervals to the left by pi, which starts at here. Okay, but if you can see your graph, this graph starting at this point B is a sine function, not a cosine function. So this does not work. All right, next, for part C, we have plus pi over 2, which means we're going to go left by pi over 2. Starting here, that's C. And we can see at C, we go down 2, up 2, up 2, which would match our graph. So C is the other answer. Let's do D just for good practice. We again have plus pi for our horizontal shift, which starts at the same place that B was. But the reason that D does not work is that at the point D, or B, either one, the graph goes up first, which means it is a positive sine function, not a negative, like the equation is. Okay, so that's why D does not work. It's in the right place, but it's going the wrong direction. Okay. For the next couple problems, we're going to look at what the equations are, or the graphs, and see if we can figure out what the periods, amplitudes, vertical shift, or horizontal shift are for each of these functions. So let's look at these. We have the period, the amplitude, the horizontal shift, and the vertical shift. Oop, I did the wrong order. There we go. Vertical shift and horizontal shift. Oh, I lied. Hold on. My apologies. It's down here at the bottom which one we're looking for. Okay, so 15, we're looking for the period and the vertical shift right here. So the period of this graph, because the x is being divided by 7, and it's a cosine function, this graph should have a period of 2 pi. Right? But it's going to be multiplied by 7 to get x by itself, so x will equal 14 pi. So that is our period. As for the vertical shift, this number on the outside is your vertical shift, so you're going up by 8. All right, for this problem, make sure your directionality is correct. You're going up, down, left, or right. All right, put that down on the test. Next, number 16. I know it's 16, for some reason that number's way over there, but this is 16. We want to find the period and the amplitude. Okay, so for the period, if we start the graph on the y-axis right there, and we do what looks like to be a cosine function, we are ending right here, and that is our period. Our period is pi. One rotation around the unit circle, so one graph, not all the graphs together. Okay, so our period starts at the y-axis, and goes up, up, down, down, and ends at pi. So that's our period. All right, for the amplitude, there's a couple ways you can look at this. You can look at the midline of the graph. Okay, or you can take the total height of the graph and divide it by 2. Okay, so if you take the total height of the graph, we got -1, it goes up 1, 2, 3, and 4. So the total height of the graph is 4. But we want the amplitude, which is half of that, so you divide that by 2. So the amplitude of this function is 2. All right, if you want to think about it here, if you looked at the graph and cut it in half vertically, there's 2 going down and 2 going up. Amplitude is still 2. Okay. For 17, we're looking for the period on the vertical shift. The period is being changed by the x is multiplied by 4. But for a tangent function, the period is going to be pi. So we're going to divide both sides by 4, and the period is pi over 4. Okay, your vertical shift is this number right here, which is plus 10. So we're going up by 10. Now for 18, this is a little bit more complicated. What you're going to do is you're going to draw a sine or cosine graph inside this function, because it could be a secant or a cosecant. So how I'm going to do this is I'm going to do a dashed line and go through and draw my graph, because it's easier to see using sine or cosine what this graph will look like. Notice how I've gone to each one of the peaks or valleys where my parabola type shapes are. Okay, so if I look at starting the y-axis here and doing a cosine function all the way to here, my period is 2 pi. Okay, as far as my amplitude goes, so the total distance of the graph, it goes from -1 to +1, which is 2. Divide that in half by 2, which is 1. So the amplitude of that graph is 1. All right, so hopefully that helps. We got 2 more. All right, what's the amplitude? So the amplitude is found in the front of your cosine function here. But the quick thing for this is amplitudes are always positive numbers. That negative sign, although it's -5, that just tells you that it's reflection over the x-axis. The amplitude is still always a positive number, so it's +5. Your horizontal shift is found by adding pi over 2, but that means because it's plus pi over 2, we're going to the left by pi over 2. Okay, again, put the directionality of your shift, like we did for the vertical shifts up at the other problems. All right, here, your period. So if we start at the y-axis and go down, down, up, up, when we stop here for our cosine graph, our period is pi. For the amplitude, the total distance from the top to the bottom started at -2, goes to +4. That's a total distance of 6. Divided by 2 for half of it is 3 for your amplitude. Okay. All right, finally, we're going to look at some graphs and find the equations of these graphs. All right, a lot of it can depend on where you're starting your graph. I'm going to try and make it as easy as possible. If you can, start at the y-axis, all right, because then you don't have to do any shifting. So this graph here, I'm going to change colors for this. The graph here, since it goes like that, is a cosine function. Okay, so let's build it out. Okay. What's the amplitude? So we go from 0 to 4. Divide that by 2, which is 2. That is your amplitude. Okay. All right. The period from the beginning to the end of the graph, right here, is 2 pi. So that is not change in a cosine graph. So we're not multiplying or dividing anything on the x term, so that's just going to be x. Since we started at the y-axis, there is no horizontal shift, so we can just close that parentheses. All right, but our first point is at 4. Okay, so if cosine is 1, we're multiplying that by 2. How do we get 4? Well, we add 2. That will give us 4. So we're going to add 2 to our equation. And there you go. 2 cosine of x plus 2. All right, let's look at 22. Again, if we start on the y-axis, we go down, up, up, and down. We've just drawn a a sine function. Okay. All right, if we look at the total distance to find the amplitude, it goes from -3 to +3, which is a distance of 6. Cut it in half, we get 3. But if we notice when we did our graph, looking at it, it goes down first rather than up first, which means this 3 must be negative. Okay. Our period from start to finish is still 2 pi, so nothing is being multiplied or divided by the x term. And since we start on the y-axis, there is no horizontal shift. And since we start at 0, we have -3 times sine is 0. It starts at 0, so that's good. We don't have to do any vertical shifts either. Okay, if there was a vertical shift, that would mean the first point on the y-axis would be something else besides 0. So this is our equation. Okay. For number 23, like I did before for a problem up above, I'm going to draw in the sine or cosine graph to help us visualize better what's going on in this function. There we go. Okay, so what I'm going to do is I'm going to start this here at 0. That allows us to be a lot easier as far as there's no shifting because I'm starting at 0. Okay, if I start at 0, then that graph is a sine function. But we're graphing the blue lines, not the red ones. So sine would be cosecant. For the amplitude, we go from -2 to +2, a total distance of 4. Divide that by 2 for your amplitude, which gives us 2. The graph does go up first, so that means the sine function is positive, so our cosecant is also going to be positive. So I can do y equals 2 cosecant. All right. From the start of our graph to the end of our graph is 2 pi, so that means x is not multiplied or divided by anything. Since I started on the y-axis, that means there's no horizontal shift. Okay, and because I started at 0, there was no vertical shift either. So this is the equation for this graph. I'll rephrase it. That is one of the equations for the graph. You can make others if you wanted to, but I think that's the easiest one. All right, lastly, this one's a little tricky. So it's in the shape of a cotangent graph, but it's right here on the axis. So I could do a cotangent graph with a horizontal shift, or I could do a negative tangent graph, all right, which would flip the graph upside down, which is probably a little bit easier. Okay, I'm going to show you both. So because your graph is here at -pi/2 and +pi/2, all right, the period is not changed. All right, so if we did a tangent graph, we would have to flip it upside down by putting a negative in front of it. We'd have x because the period is still 1 pi long from -pi/2 to +pi/2. We could also make this a cotangent graph. To do that, what I'd have to do is I'd have to have a horizontal shift for it. So it got moved over 2 spots to the left. So that means I would put down plus pi/2. Okay, that would allow me to move the graph 2 spots to the left. Now, either one of these equations is correct. It doesn't make a difference which one you pick. They are both correct. Okay, the same thing could be said for the other 3 that we did. There is more than one equation for these problems. Okay, I'll give you a good example. If we go up to number 22, let's do this in orange. If I started the graph here, I'd have the same equation, but I'd have a horizontal shift by the x of plus 2 pi. Okay, it'd be the same thing, but I could put down -3 sine of x plus 2 pi. Okay, that is still a good equation for this graph. It would just have a different starting point. I wouldn't necessarily recommend that because you're adding more complications to your graph, but you could do it if you wanted to. Okay, so that is it, actually. That is the entire review. Please make sure you're practicing these things. Ask questions if you're not sure about something. And